The invisible force. Noah was eating an apple at the window when it slipped from his hand and thumped onto the floor. Liam picked it up and handed it back. "Why does everything always fall down?" Liam asked suddenly. "Why doesn't the apple ever fall up, or sideways?" Noah paused mid-bite. That is one of the greatest questions anyone has ever asked. In fact, a man named Isaac Newton asked that very same question about 340 years ago, and he changed the world by answering it. The telescope glowed, and the brothers found themselves in an English garden in the year 1666. Sitting under an apple tree was a young man with long, wavy hair and sharp, curious eyes. This was Isaac Newton, only 23 years old, watching apples fall from the tree above him. Newton's great idea. "I wonder," young Newton murmured to himself, "if the same force that pulls this apple to the ground also reaches up to the moon and pulls on it too." This was his brilliant insight. Newton realized that there must be an invisible force, he called it gravity, that pulls every object in the universe toward every other object. The bigger something is, the stronger its pull. "Earth is very big," Noah explained to Liam as they watched Newton scribble equations with a quill pen. "So its gravity is strong enough to pull everything toward its center: apples, raindrops, you and me. That's why things fall down. Down just means toward the center of the earth." "But the moon doesn't fall down to earth," Liam pointed out. "Why not? It's actually falling all the time. But it's also moving sideways so fast that as it falls, it keeps missing the earth. It falls around us in a circle, that's what an orbit is. The moon is constantly falling toward Earth but constantly missing." The telescope showed them a view from space, the moon sailing around Earth in its endless orbit, held in place by Earth's invisible gravitational pull. And Earth itself was orbiting the sun for the same reason. The sun's enormous gravity held all the planets in their paths. "Gravity holds the entire solar system together," Noah said. "The sun holds the planets hold their moons, and even distant galaxies are held together by gravity. Without it, everything in the universe would just float apart." Liam jumped as high as he could. "So gravity is what makes me come back down?" "Every time. On Earth, gravity accelerates everything downward at the same rate, about 32 feet per second per second. That means after 1 second of falling, you're going 32 feet per second. After 2 seconds, 64 feet per second. Gravity doesn't care if you're a feather or a bowling ball. In a vacuum, without air resistance, they would both hit the ground at exactly the same time. And gravity is what gives us weight," Noah added. "On the moon, which is much smaller than Earth, gravity is only 1/6 as strong. So if you weigh 60 pounds on Earth, you'd weigh only 10 pounds on the moon. You could jump 6 times higher." The mystery of magnets. The telescope carried them forward in time to a market in ancient Greece, about 600 BC. An old philosopher named Thales was showing people a strange black rock from the region of Magnesia. When he held it near pieces of iron, the iron jumped toward the rock as if pulled by invisible strings. "This is a lodestone," Noah said, "a naturally magnetic rock." The ancient Greeks didn't know why it attracted iron, they thought it had a soul. But we now know it's another invisible force, magnetism. The telescope brought them to a workshop where they could experiment. Noah held up a bar magnet, a rectangular piece of metal painted red on one end and blue on the other. "Every magnet has 2 ends called poles, a north pole and a south pole," Noah explained. "Here's the amazing part: opposite poles attract each other, and same poles repel each other." He held the north pole of one magnet near the south pole of another. They snapped together with a satisfying click. Then he flipped one magnet around so 2 north poles faced each other. Liam could feel the invisible force pushing his hands apart. It was like trying to push 2 basketballs together underwater. "The force is real, but you can't see it," Liam marveled. "Just like gravity." "Right. And here's something incredible: the entire Earth is a giant magnet." Noah showed Liam a compass, a small circle with a magnetized needle balanced on a tiny point so it could spin freely. No matter which way they turned the compass, the needle always swung back to point north. Deep inside the Earth, the outer core is made of liquid iron and nickel, swirling and flowing. This creates a magnetic field around the whole planet, just like the field around a bar magnet. The compass needle is a tiny magnet, and it lines up with Earth's magnetic field, always pointing toward magnetic north. Sailors have used compasses to navigate the oceans for over 1,000 years, Noah continued. Before GPS and satellites, a compass and the stars were the only way to know which direction you were traveling across the open sea. Magnets in our world. Magnets are everywhere in our modern world, Noah said as the telescope showed them different examples. Electric motors use magnets to spin, that's how fans, washing machines, and electric cars work. Speakers use magnets to vibrate and make sound. Doctors use giant magnets in MRI machines to see inside your body without surgery. Even the magnetic strip on the back of a credit card stores information using tiny magnetic patterns. And here's something Newton would have loved: gravity and magnetism are both invisible forces that act across empty space. You don't need to touch something to push or pull it, these forces reach out across the gap. Liam held the compass in his hand and slowly turned in a circle, watching the needle faithfully track toward north. So right now, an invisible force from deep inside the Earth is moving this tiny needle? From almost 2,000 miles beneath your feet, Noah confirmed. An ocean of liquid iron, spinning and swirling, sending its magnetic force all the way up through rock and soil and into that little needle. They were back in their bedroom. Liam put the compass on his nightstand next to the fossil ammonite. Two treasures now, one from the ancient past, one pointing always to the future. Gravity pulls me into bed, Liam said with a yawn, snuggling under his covers. And that's one invisible force I'm happy about. Me too, Noah laughed, clicking off the lamp. In the darkness, the telescope gleamed softly, ready for tomorrow's adventure.